Hello guys. Let's wait a few more minutes. Okay, last time we stopped at Dijkstra's algorithm, okay? And I gave you some hints about my coding in Matlab. I will start this lecture by highlighting it again in a very simple example and with no writing. I made some animation for you. Maybe that would be a better idea to give you the idea of the coding itself. So as I said, I created in each iteration to choose a frontier, we choose the frontier with the minimum cost to the starting node, okay? So I made an array, which is exactly the map array, and I filled it all the element except the starting node with infinity, just like what you see here, okay? And before beginning this example or this animation, okay, let's have some writing here. Yes. Okay. So here is the starting node, here is the goal node, and as you see, all the costs are infinity except the start node. Okay. So besides this array, I will create another table or array again with the node ID and the parent, because we need the parent to trace the shortest path. Okay. So in the first iteration, I have only one frontier, which is the starting node here. So I will start, of course, by the starting node. The starting node will explore 3 more nodes because upper node is actually an obstacle. So we have this node and this node and this node. So let's see what will happen after the first iteration. So the first iteration, I picked this frontier, which has the minimum cost. Now remember, all the entries of this array has infinity as entry, except the starting node has 0. So when MATLAB searches for the minimum, it will find only one cell, which is the starting cell with the minimum cost, 0. Okay, and this starting nodes, which has ID of BC. Sorry, starting node is BC, not AC. I'm very sorry for this. It should be BC, not AC. Let's correct it here. That's fine. So BC. Oh. Okay, so BC. BC, BC, BC. Okay, this is a starting node. It will discover 3 more nodes. This node here, this node, and this node. This node has an ID of PB. That's right. This node has an ID of PD. That's also right. This node has an ID of CC. So let's just to correct this. So this is CC. Okay. Now the step that maybe most of you didn't understand quite well. Okay, now I finished exploring the starting node. I need to pick another node, another frontier, okay, to explore around them also. So if I just keep, so after this step, now we have all the entries except again with infinity, except 4 cells. The cells that starting node has discovered, which has a cost of 1. Here all the cost is 1. And the starting node itself has a cost of 0. So if I search it in that array for the cell with the minimum cost, it will be again the starting node, because starting node has 0 and the nodes around has 1, then infinity. So I need, in order not to choose it again, okay, before choosing or selecting a new frontier, I need to mark the previous frontier with infinity. Okay, so I will mark this cell with infinity, so that when I run the code in Matlab to find the minimum in that array, Matlab will return one of those, either this one or this one or this one. Okay, that's clear? Okay, so let's now make another frontier. Now we market this node with infinity again. Okay, now we have only 3 nodes with 1s, everything else with infinity. So if I did this, Matlab will return one of those, and it will return the one on the left of the infinity node. Okay, but again, you can control this and choose any one of them randomly. That's fine. It's very fine. So we now have a new frontier, which is this one. Okay, so this guy, which is BB, this is our new frontier, will discover 2 new nodes. One of them is the goal, and this one, which is above this cell. So this cell as AB or BA, whatever. Yeah, BA is the goal. This is the goal. That's good. And the other one, which is AB. And both have the same parent, which is BB. And both have cost of 2. 2 cells away from the starting node. Good. Now we have 5 cells with entries rather than infinity, and all other cells with infinity. I have 3 cells with 1, cost of 1, and 2 cells with cost of 2. If I run minimum again, Matlab will return me the same node, this one. So I need to exclude it, to mark it, so that Matlab will not return this again. So I will mark it again with infinity, just like the starting node in the previous step. So that now we have 4 cells with entries rather than infinity. This one was cost of 1, this one was cost of 1, this one was cost of 2, this one was cost of 2. So of course, the minimum here is 1s. So Matlab will return either this one or this one. In specific, with my implementation, it will return this one here. Okay, let's see the third step. Yes, it returns that guy. Okay, that guy, has only one unexplored node. Remember, this was the starting node, so it will not be explored again. So it will only explore this one. And again, the distance from the starting node, which was here, is only 2. So I will mark it. I put 2 there and put it in the table here. So this new cell has ID of CD, and its parent is CC, this one, CC. Now I have 2 cells still with 1, this one and this one, and 3 cells with 2, this one, and this one. Again, if I run the minimum, I will return this, the same frontier. So I must mark it with infinity again. Now I end up with 4 possible frontiers. This guy, this guy, this guy, this guy. The minimum, of course, is that cell. So let's see the 5th step. In the 5th step, we return that cell. Okay, that cell has a neighbor here, which is a starting node, so it's already an explored frontier. Okay, and we mark those in another array that I will show you in the code, which is the map array, the color map array. And this cell here already explored by another cell, and the distance is the same from the start. If I want to go from the start to this node using the new frontier, the cost will be 2, or the previous frontier, which is the cost is 2. So we'll just ignore it. But this guy in here is not explored before. So this will add a new entry here, a new explored cell, which is this one with a cost of 2. Because the distance of that one from the start is 2. Okay, this one has an ID of PE, and its parent is this one, which is BD. Okay, again, if I run the minimum, it will return this one again. So I must mark it with infinity. Now I have 4 nodes with entries equal to 2. The others are infinity. This one, this one, this one, this one. If I run the minimum, Matlab will return the first one it encounters, which is the goal node actually. So we finished. So in the 6th step, we discovered the goal. That's it. Okay. We may add the goal here. We already had the goal. So the goal here, I'm sorry, we already had the goal. And the goal has, so here is the goal. Its parent is BB. So BB, where is the parent of BB? This is BB. The parent of BB is AC, which is actually the starting node, which is here. Obviously, the shortest path should be in that way. Okay. I hope, now we took 2 examples of the same stuff. So this is maybe an easier one than the one in the last lecture, just to avoid any confusion I caused by the previous example. So let's now check the codes. But before checking the codes, okay, let's explore first the operation or the cost, the time, the stuff of both breadth first search and Dijkstra's when you have a non-uniform map, which really will show you the benefit of using Dijkstra's. Okay, so I have here a very good example, the one that I showed you last lecture, which is this one. Let me show it very, very quick. Yes. Yeah, this one here. So this example here, if you remember, let's see. Yeah. So this one here, if you remember, this cell has a cost of 100, while all other nodes has a cost of 1. So the shortest path was that way. So let's see. I think I have this example here in my coding. I just forgot for some reason. So let me check with you very quick if I have it. I think it should be that one. Let me see. Yeah, it is that one. So in here in the code, okay, this is a breadth first search. I didn't touch it. I just added some lines of code. I will show you these lines, okay, that add some cost, because in the beginning, in the code that I sent you before for breadth first search has implicit, assumptions that all the cells has a cost of 1. But now with non-uniform cost, you must put some code in your coding, in your program, so that it will define the cost for each cell. And this is what I have done. So in that particular example, let me see if we run it. I'm sorry. If we run it again, You must run the code from the main, not from the function. If we run it again, yes. So good. This is the starting node, the yellow one. This is the goal node, the green one.
Professor?
Yes, Saul. Yes.
Are we supposed to be looking at your Matlab code, or?
I'm sorry. Yeah, I'm very sorry. I will share the other screen. Thank you very much. I will share the other screen.
Okay.
Thank you. Okay, now the Matlab, right? Okay, this is the same example that I just showed you on the tablet. Okay, see here the same map, exactly the same map, and I added some part in the code, some very little coding, is a very easy one, to mark this cell with cost of 1,000. Okay, other cells with cost of 1. So because Breadth doesn't look at the cost of each cell, it just explore around without any, any attention to the cost, to the cell it explores. It will think the best path is the one with the least number of steps or least number of hops. Just here 2 hops from the start to the goal. Also, the cost of these hops, if you look here, it's 1,000 because this is the 1,000. Okay, and the number. Let me get that like this. Yeah, and the number of steps explored is 11. Let me see if I have another. And the route is basically, this is 27, this is 37. So we just 2 hops to the goal. Okay. So this is, let's check the same with Dijkstra's. So this is example number 7. Here is Mr. Dijkstra's. Number, no, that's fine. It should be the same. Uniform of false. Let's see that guy. Good. Good. So Dijkstra's clearly avoids this, bad cell in between and take another route from the start to the goal. Okay, and the cost is just 102. I will explain why it's 102 because here I made some, in this cost I made some, assumptions. So basically I marked all the cells that beside any obstacle with a cost of 100. Okay. Just to avoid the obstacle, something like this, unless you don't have other options. So that's why it's 102, because this one has a cost of 1, this cell has a cost of 1, but this cell, since it's beside a wall, it has a cost of 100. So 1 plus 1 plus 100 is 102. Okay, so the cells here, any cell beside is beside or neighbor to an obstacle, it has a cost of 100. And this in particular, the cell between the start and the goal has a cost of 1,000. Okay, breadth first search just take the path with the least number of hops or steps, which was through this middle node, and the cost was 1,000. But this guy here is smarter, so it goes through this cell and this cell. Cost of 2, then this cell, cost of 100 is still 1 to 10 because the other one is 1,000. Okay, so that's a very clear example for how the Dijkstra works with non-uniform grids or maps. Let's take now another example that to make it more and more clear for you. So okay, let's now comment this guy here. And I'm very sorry, comment. Okay, it's commented now. Let's take that one. Should be similar. Okay, that's good. Good. So here, the guy, try to avoid this because this is a neighbor to an obstacle, and the cost of 104. Let's see what Brett's first search will do for the same example. So here we have 30 steps, and the total cost is 104. Maybe Brett's first search for that particular example will be the same. Let's see. More similar. So here is this guy. Comment this. Uncomment this. And let's see what we have. Wow. So it took 1,000, and the reason here because I again mark one of the cells around the starting node with 1,000. So in the previous example, it was that one, okay? Here I think one of them again was 1,000, but I think this one. So the British Prestige doesn't look at the cost and just take, whenever, or whatever path with least number of steps. Okay, so in all the examples we have, I mark one of the cells around the starting node with cost of 1,000. And the cells beside obstacles with 100. Other cells with cost of 1. Okay, but anyways, you see that Brett's first search doesn't look at the cost entirely, and that's what causes it to have, paths with very high cost rather than Dijkstra's. Let's see another example. And it also takes, for this particular example, it also takes 32 steps. If you remember, Dijkstra's only took 30 steps. As I said, they are comparable in the number of steps. We may find other examples that Brett's first search take less number of steps. But for the cost, no. Dijkstra's is the best for sure. So let's take another example. Uncomment. Here again, one of the cells around the starting node has a cost of 1,000, and Brett's first search is just myopic of this, and they will take it. This was the one in here. Okay. For the same configuration, let's see what Dijkstra will do. So let's commit that guy. Take that guy. So remember 1,029. We have the same configuration, same cost. Let's see what Dijkstra will do. Look, it avoids that cell here, which has a cost of 1,000. Okay, and yes, it's the path that Dijkstra took has more hops, more steps, but the cost is less, only 6. Oh, goes away. Only 6, because these cells that Dijkstra took are away from obstacles, so they don't have a 100 cost, and also they are away from this cell that has a cost of 1,000. Okay, so there is no comparison. The other one took 1,000. Okay, let's take another example. This one with a bigger map. Let's uncomment and run this. So Dijkstra's now will avoid those cells just below the obstacle, because those one has higher cost. Look, so it avoids those ones and also those ones. And the cost is only 14 and the steps is 78. Let's do the same with Mr. Brett's first search. Let's comment that guy. And let's have this guy. That guy is very stupid. So you will see it will explore those nodes here, although they have, higher cost. and probably the path will be through these nodes also, because this is the path with least number of hops. Each cell here has a cost of 100, so we'll have very high cost. Remember, with Dijkstra's it was 14 and 78. 14 as a cost and 78 steps. We're almost there now. Wow. So it's 979. So it's just one extra step in exploration. That's fine. They are comparable, but the cost is very high. Okay. And there are many other, we have still two. Okay, let's do them very quick. There will be no much difference here because there is only one cell in breadth first search that has higher cost, which is 100. Okay, 107. Okay, so let's see the other guy. Look, it avoids this cell. And also this one. This one has a cost of 1,000. I told you, yeah. So just cost of 8. The other one was cost of how much? So it goes away. It was 100 something, right? 107. Yes, it was 107. Now the cost is only 8. Okay. And you have another example here. All of them are, will show you the difference between them. Okay, let's now explore my code for that. Okay, it will be as a similar, very similar to breadth first search or Dijkstra's. I'm sorry, to depth first search. Very similar. Also, I added some other coding to add the cost. This is not a part of the Dijkstra's algorithm at all. This is just, you can consider this as inputs for you, that this cell has a certain cost, this cell has a certain cost. So don't worry if you didn't understand this part. But you should understand it because it's very easy. Okay. And of course I put other, other parameters just for the purpose of educating you. Okay. Like, for example, I added here a parameter called uniform grid. It's a Boolean variable, okay, that tells the algorithm if it's a uniform or not. If it's uniform, the cost of each cell will be 1. Okay. If it's false, that means it's not uniform. So the code that I put in the function that distributes the cost between cells in a certain way will work. And hence you will have a non-uniform grid. So we control the cost, whether it's uniform or not uniform, using this Boolean variable called uniform grid. If it's true, it's uniform, the cost is 1 for any cell. If it's not uniform, if it's false, then it's not uniform. And I will show you if it's not uniform, how we gonna distribute the sets. Although this is just an input for you. I also added here an output, which is the total cost. Okay. It just explores from the goal to the parent, and in this path, calculate the cost of each cell on the path so that you could know the total cost. And
Professor?
yes.
Just a quick question. When calculating total cost, we're not taking into account the cost of the goal node, right?
Yes. So here I made, because the goal node is, whenever you run an algorithm, you should reach the goal, right? Yeah. So it's common for all. I mean, if its cost is 1,000, it will be added to, you must reach it from Dijkstra's from breadth first search, from depth first, whatever the algorithm that you are using, you must reach the goal. So you must add its cost. So I want its cost is 0, but of course you can add it with whatever you want. But usually in any algorithm, rather than even the ones that I'm not writing, I mean, if you search on the internet for codes that have costs for the cells, you will find the goal has zero cost. Okay, it's not counted because whatever the algorithm that you are using, it must reach the goal. Shouldn't avoid it. Okay, even if it's high cost. Good. So I added also here this new variable here, uniform, so that I sent its value, whether it's true or false, so that in the algorithm, in the code of the algorithm, okay, I will know if I should add a cost or not for each cell. So let's go to the coding itself. So still the same. The color map that we talk about it maybe 1,000 times till this moment. And here we just extracting the number of row and columns of the map, the input map, creating the color map, okay, and again marking, free cells with white, obstacle cells with black, all that stuff we did maybe 200,000 times before, okay. Then here is the part of the cost, okay. So I just create an array, which is exactly has the same, the same size of the input map, and I initialize it with ones. So you can do that in very easy way using Matlab, just ones of whatever size you want. So then Matlab will create an array for you with the input size, which is exactly the size of the input map, the same number of rows, same number of columns, and initialize it with ones. Okay, very easy way, just one line. And here, I am asking myself if it's a uniform grid or not. If it's uniform grid, this will be false. Then this will not be, these two functions here, or these two snippet of codes will not be executed. Okay. If it's if this guy is false, which means it's not uniform, it's not will be true. So I will, execute this and execute this. So what does this do? It's very easy. So I know that breadth first search, takes the shortest path based on the number of hops. So the closest cell around the starting node to the goal node would be taken most of the cases, okay, in the route. So I marked this particular node with high cost, so that to show you the value of the Dijkstra or the high cost that breadth first search will incur if it's executed on non-uniform grids. Okay, so it's very basic code here. I'm saying that if the start node coordinate of 1, which is the row number, is larger than the destination row number. So this is the coordinates. The start coordinate, remember, has 2 elements. It's a vector that has 2 elements: the number of rows and the column number of the row of the starting node, and the column number of the starting node. And destination coordinate again, contains both the row number of the destination node or the goal node and the column number of the destination node or the goal node. Okay, so I'm saying here, if I am I'm comparing the rows right now. So if the row of the start is larger than the row of the destination, which means the start node is somewhere below the goal node, I will mark the node above me, above the starting node with 1000. Okay, so that I know that Brits first search probably will take this cell. So when the Brits first search took it, it will incur higher cost than Dijkstra's, because under Dijkstra's will avoid it for sure. Okay, unless it's the only way. So that's why here I am doing that little coding in here to mark one of the cells around the starting node, the closest cell to the goal node around the starting node with higher cost. Okay, that's good. So this is code here, and here I'm comparing the four possibilities. If it's above me, below me, if the goal is above the start or below the start, on the right of the start, or on the left of the start. It should be somewhere in those locations. Okay. Okay. The other, coding that also add cost to the grid or the map is the one that adds the cost to the cells just beside the wall or the obstacles. Okay, so I am marking here the cells beside the obstacles with higher cost. That's in nature means that you are just walking, for example, on an edge of a cliff, for example. Okay. So that's maybe risky to do that. So I am giving higher cost to those cells. Unless it's the only way to reach the goal, I will explore them and take them in my path. Otherwise, I will not do that. Okay, still they are valid cells, but if you took them because your algorithm is stupid, like Brits first search, or you don't have other ways, you are trying to avoid it, but there is no other way to the goal, then you have no choice and you should take it. But it will incur higher cost. Okay, so that's what I'm doing in here. So I am looping over all the elements inside the input map. This means Newman. This function here called the Newman. It's very very good function in Matlab. This will return the number of cells in the array. Okay, so Newman input map, if the input map, for example, has 100 cells, so this will return 100. Because I want to loop on all the cells in the array. Then I'm saying this is the following. If input map of node, okay, if it's free, because if it's not free, that means it has a wall. If it has a wall, if it has a wall, it will be true. Remember, input map has two values. The interest has two values: zeros for the free cells and one for the obstacles. So it's true for the obstacle. So I'm saying if it's an obstacle, okay, then mark the cells neighboring that obstacle with cost of 100. Okay, so here I'm asking if it's an obstacle. If it's yes, it's an obstacle. I am getting its row and column indices. Then I am searching for its exploring its four neighbors. If I find any neighbor to this node not obstacle, then I will mark its cost with 100, which is high cost here. Okay, that's what I am doing in that code. It's really very simple one. I am sure you guys, experience this in the homework and understand it very well. Or I hope so, we can say. Good. Now, now this is a very good, this is actually the array which has the same size of the input map, and it has infinity everywhere, except the frontiers that are not explored yet. Okay, so remember the tablet. Let's go back to the tablet to show you what I'm talking. What this array is doing. Distance from start. So let's go back to the tablet to show you. This array here is actually this one. This array, okay, which is distance from start, is actually this array here, which filled of infinity, except the nodes that will be explored in the future. And if I take a node from it and mark it with infinity, explore around and mark with infinity, of course I will not explore it again. Okay? So let's go back to the coding. I am very sorry, you know, it's not convenient at all to do, you know, multiple sharing for the screen. I know it may be confusing as well. But anyway, so this array here, this is now the first thing that I created for Dijkstras, okay? And this cells has just infinity everywhere, and of course it has the same size as the map, okay? This is now the second array, the table that I just showed you beside the array, which contains the ID of the parent of each node. Okay, I did it in this way. So it is, as you see here, it has the same size as the map. Okay, and it has all zeros. And remember, in Matlab, there is no ID called zero ID. You are starting the IDs by 1 until the end of the array. So no cell in the array should have an ID of 0. So if an array that if in this parent array, if a cell has a 0, that means it was not explored yet. Because if it's explored, I will put, instead of this 0, I will put the ID of its parent. Okay. Good. That's just initialization, or you know, creating a new arrays. Now I will put, you know, remember distance from start now contains all infinity. I will mark only the starting node with 0, the starting node location. Okay. So this will be the first node to explore, because with this step here, this array has infinity everywhere except the location of the starting node, which was step number 1 in the tablet here. So let's go back to the tablet to make it clearer for you. Let's verify. So what I am doing right now is creating this array. I create it, put infinity everywhere, then remove the infinity from here and put 0. Okay. Then when I run the code that will give me the cell with the minimum cost, Matlab will return this node, which is the starting node. Okay, so let's go back to the coding again. And here I am just, you know, keep tracking of the number of steps, and also I keep tracking of the number of frontiers explored. Okay, this should be less in Dijkstra, but this is not important. Now we go to the infinite loop, same infinite loop that we saw before in breadth first search or depth first search. This is only for drawing. Okay. Now here is, I am selecting the new frontier. Okay, where I should look for frontiers. I look for frontiers in that particular array that has infinity everywhere. Okay, except in the explored frontiers. Now we have only one, which is a starting node, which has 0. So currently with this step here, this array has all cells with infinity except the starting cell has a content of 0. So it is a minimum. Now this cell, which is a starting cell, is the cell with the minimum cost. So based on that, I will get here. So if I just run this, very simple command in MATLAB, MATLAB will return to me the cost, the content of the cell, which is actually the cost, and the cost from the start is just 0. Okay, and its ID. Okay, I call it current because it will be the current frontier. Okay, let's change it. Let's make it current to make it more clear for you. Let's call it current frontier ID. And in MATLAB, just follow what's a shift enter will change every occurrence of that variable to the new name. You see, very easy one. So this has the current frontier ID. Okay, and it's a distance from the start. And currently, since we are exploring around the starting node, so the distance is just 0. Good. Here, just like again, let's first search and the other ones, I'm saying if this is the goal node, break the loop we have finished. And remember, I break the loop in 2 conditions. When I reach the goal, or if there is no other frontier to explore, which means there is no way or there is no route to the destination or the goal. So in previous codes, I used to make them in a separate condition, just to make it clear for you. Okay. Here I'm just combining them because the result is the same. If it is a goal or there is no other frontier, just to break the loop. Okay. How could I know there is no other frontier to explore? If I find that the minimum distance from the start is infinity, that means that all the frontiers has been explored and I couldn't reach the goal. So basically, if there is no route to the goal, I will find at this step that all the entries of distance from the start array is infinity. And I will choose that in one example. So that's the mark that will tell us that there is no route to the destination or the goal node. Okay. Okay, we got our frontier. Then we mark it in the color map with red. That means, so when you see red, you know that this is a frontier that will be explored around. Okay, and this is a very important step that I always telling you, that you must mark its location in the array with infinity, so that you will not explore it again and again. Remember now, this array in the first step has all content as infinity except the starting node, which is 0. If I keep it 0 and didn't do that step here, then in the next iteration of the while loop, I will have maximum 5 nodes with non-infinity entries. The starting node and 4 nodes around, if there is no obstacle around the starting node. The start will have 0 cost, and the other node will have some, finite cost, not infinity. If at this second iteration, still the location of the starting node has 0, so this line here will return the starting node again to explore, which is wrong, because I already explored it. I will go in infinite loop. by that. So here is the way I am, marking the explore the frontiers so that I will not choose them again to explore. Good. We have a frontier, we marked it so we will not return to it again. We get its, coordinates, row and column, and explore around that frontier. Up, right, left, down, as usual. And again, we have, our checks. Skip if this is, if this is outside the map. Oh, this is, yeah, we can write it in that way or in that way. So skip if outside the map. Okay. That's not important now. Then, if it was, a frontier before, okay, I should also skip it. Remember, in all my explanations, I always avoid to explore previous frontiers, and we usually mark them. Okay, either in that in the example that I just showed you in the beginning of the lecture or last lecture. Okay, I always avoid visiting or exploring the frontiers that was explored before. How could I know that? I will find its color in the map equal to 3. That's why, okay, or that's how I mark previous frontiers that was explored. I will find them, I will find their entries in the map with 3. That means, which is red. That means that was there was an explored frontier here. So don't explore it and skip. Go search for another neighbor. So I make here a continue. Then I check if it's a barrier. Again, if it's a barrier, then I should skip. So let's write it in that way. Skip if barrier. By the way, this is my code. The code that I sent you has a little. It's the same coding. I mean the same Matlab, but the comments are different. That's why I'm I'm changing stuff here. Okay, but you will find it using skip in your code. Okay, if we pass all those checks, then this new cell was not explored before, okay? And I should mark it. I should mark it with not with something rather than infinity, because now, currently, just before that line, the entry of that cell, that neighbor, in that array, distance from start, is currently infinity, which means I don't know a route to this cell yet. So I'm just marking it infinity. That's why I put infinity there. But now we discovered the route to that neighbor of the frontier, and we know its cost. It should be the cost of the frontier, the parent, plus the cost to reach that cell. Remember, each cell has its own cost. So the cost now of that neighbor is equal to the cost of the frontier. Remember, this is the cost of the frontier. Plus the cost of that neighbor, which will be located in the cost array, the ones that we created based on the non-uniform or non-uniform variable. These variables that we put true or false. If you want a uniform cost with 1 or non-uniform cost. Then we mark the neighbor, the name is the ID. We mark or we put the parent of that neighbor in the parent array. So I'm saying here, the parent of this neighbor is equal to the current frontier ID. because this is the frontier that discovered this neighbor. So it's neighbor. Here I'm just incrementing the steps. That means increasing the number. I explored more nodes. Okay. This is the exploration step. Again, making sure that the goal is still yellow, not to change it, and then draw the map. Okay, let's see that in action step by step. Okay, and check, step by step the graph, the plot, the map, the color map, and also this array here that has infinity everywhere, just to give you an idea what's happening. So I will put, yes, I will put here, what's they call it? I don't know, bullet point or break point. And then I will run the code. The code will stop each time in that node here, okay? So we cannot check at that point what's the content of this array, the distance from start, this mysterious array that has always infinity, except the frontier nodes. Okay, let's see what's happening exactly. So let's do that. Hope we don't have a bug. We have a bug. Okay. So what's happening here? Let's do that again. Yeah, okay. Because all of them are, all the examples are commented. So this was, the map was not, defined. So we must, let's yeah, any one of them is, I guess this one is better. So let's do that. So we're gonna uncomment this guy. Good. Now we will run. Again, we have it's a comment. I uncommented all the comments, so that's why it's stops. Yes. Okay. We have it now. So this is our graph here, okay? And let's see what we have in the beginning. We have in the beginning in that array, which have, if you look and compare the size of this array to the size of the map, you will find the same size. And only the start node has, a cost of 0. Now let's, go again. So what's happening in here? The start node, which is this, so this is the starting node, okay? It was 0 in the beginning. It becomes now infinity. If we look here, it becomes infinity. It is the one between the 100 and 100. It becomes infinity. And the cells around this node, except the obstacle, will take, their cost value to the start. Remember, the cost of any cell adjacent to a barrier or obstacle has a 100, and this one in particular, this cell in particular, has a cost of 1,000, and that's what we have here. And we mark the starting cell cost with infinite, so that when we run the minimum command in Matlab, Matlab will return one of those 100s. So let's, do another step. What happens in here is that Matlab picks the one on the top of the starting node, and now it's red, as you see in the map. It's red here. And this red node explored 2 other cells. Now let's look at the array. These 2 new discovered cells, okay, has costs 101 and 200. Why the cell which is above the red cell has a cost of 200? Because I can reach this cell using the red cell, which has a cost of 100, and this cell itself has another cost of 100. So the total cost of the starting node is 200. Also, the cost of the cell just on the right of the red cell, which is the current frontier, has only cost of 101. Because its cost is only 1 because it's not beside any obstacle, okay? But the parent cost itself, which is the red cell, is 100. So the total cost for the start is 101. And again, I marked the red cell, which is the current frontier, with infinity. So that when I run the minimum again, the minimum will be the 100, okay? The cell below the starting node. Let's do that. Let's see what will happen. Good. Exactly what we're expecting. Now the current frontier is the new red node here, the one below the starting node. Okay. And again, this new node, this new frontier, the red node, discovered the 2 new cells with cost again 200 and 101, exactly for the same reason as the previous frontier, the previous red one. Okay. And again, I marked it with infinity. So when I run the minimum on that array, distance from start, this will return one of the 2 cells with cost 101, which is above the cell with cost of 1000. I mean, either this cell or this cell, because this is a cell that has 1000. So let's run again. Good, that's what we're expecting. So it chooses the node that has cost of 101 just above the node that has 1000. This node by turn explored or discovered the 2 new nodes, and it adds them to the map. Okay, and if we continue in that, at some point, okay, we will reach the goal. So let's see if we discovered the goal. Yes, the goal we discovered. Luckily, it is the node with 103. Okay, this is the node, this is the goal node, which we discovered now. How we could know it's discovered? You will find the cost of the goal node, which is the yellow here, has it changed from infinity to some finite number, which is 103 in that example. Let's run again. Okay. Now we have 5 nodes. Okay. All these below cells are cells that are not explored yet. So this will be our candidate to choose between to choose a new frontier. Okay. And again, we choose the one with minimum cost, and it should be one with cost 103. Okay. Maybe the goal, no, another one. Yeah, the next step, it will be the goal itself. Let's see. Yeah, it was the goal in the next step. And yeah, we actually finished because it just breaks the loop. Okay. So that was like a very good example, okay, to trace point by point what's happening in the code. Okay. And we see here that, you know, Dijkstra avoids this cell here with cost of 1000 and only chooses the you know, neighbors or frontiers with less cost so that we can reach the destination with less cost overall. Okay, and the cost is 102, and we have only 20 steps. Why it's 102? Because this one has 100, this has a cost of 1, this has a cost of 1. Okay. That's Dijkstra. Okay, guys, do you have any question?
Mr. Mustafa?
Yes.
How'd you update it once every time? Did you just have to like double click continue or?
How do I?
I think he means the breakpoint.
Yeah, it's a breakpoint here. Let me run again, and maybe if we run, it will be the question will be because I couldn't understand what's exactly required.
Yeah,
So
because I would like to know how you
yes,
update it once every time.
okay. So you see now this array now. This is the first step. Okay, you have only one cell with finite number, which is the starting node with 0, which is the green one. Just to compare the entries of the distance from the start array to the map. Okay? You see the corresponding cell to the green in the distance from start array has 0, which is a starting node.
Right.
Now, what's your question?
How'd you update it once from there? Like when did you just click continue? Like,
oh yeah. So this is so we have here a breakpoint. Okay. So whenever, and this is inside the while loop. So as long as we are in the while loop, okay, we just click continue, and the code will stop at that point. You understand?
oh, so you just click it once and it'll
just once. Yeah,
oh,
just once. Then you see this green arrow here.
Right.
It stops again. So we know now this is the second iteration. So we know iteration by iteration what's really happening, so that we can debug our code, for example, or understand it, right?
Right.
So this is the second iteration. Okay. If you look at the map here, the starting node, the green node, has 4 neighbors. One of them is obstacle, so we didn't touch it. It's still infinity in the array. The above node has a cost of 100. The below node has a cost of 100. The right node of the start has a cost of 1000. So you see here now 3 cells with values, with finite values. Other values are just infinite. And why the start has infinite? Because we change it to infinite again, so that when we run this command here, it will not return as a start node again, because the start node has a less cost, has a 0 cost. So if we keep it at 0, you will have 0 and above it 100, below it 100, right of it 1000. Right. And Matlab will return the start node again to us to explore, and it's already explored.
Right.
Okay.
Can you show me the line of code that shows you like the obstacles in the map, or like the high cost? Like in this case, it would be the 1000.
Yes. Okay, so this is the part, this one here, which mark one of the cells around the start node with 1000. So we have here 2 types of costs. We have, and this is my personal choice. I mean, this should be given and dependent on the problem. Okay, but I just create artificial cost to deal with. So we have the nodes around the starting node. Okay, in this case here we have this one, and this one. This will be excluded because this is an obstacle, so we have only 3 now. I will play with these 3 nodes in my in this code snippet. Okay, on this part. So what I'm saying, or what I want to do, is that I want to mark the node around the starting node, which is closest to the destination or the goal, with very high cost, which is 1000. So let's see. We have here 3 nodes around the starting node. Now you answer me. Which one of those, Johnny, is closer to the yellow cell, which is the goal? The one on the above, the one on the below, or the one on the right?
It'd be the right.
It will be the right? Mm-hmm. Good. So this is what I'm doing in here, actually. So I'm checking the location of the destination, okay, with regard to the starting node. So basically what will happen in that code is that if I find that the destination or the goal is on my right or right of the starting node, I will mark the cell which is on the right of the starting node with very high cost.
Right.
Okay. So in that particular code, this node will be marked with cost of 1,000. Why? Because this is the right on the right of the node, of the starting node, and also the goal is on the right of the starting node. Okay. Now the second type of cells are the cells which are, you know, neighbors to the obstacles.
Mm-hmm.
Okay. Which, for example, in that case, these cells here, and also those ones around that guy, and this one around this one.
They're gonna have a cost of 100.
Yes. So basically what I'm doing exactly, I have the map. I have the input map.
Mm-hmm.
And that input map, this is not the color map. This is the input map itself. It has two entries, either free or obstacle. Free is marked with 0. It's like false. And the obstacles are marked with true, or 1. So I make a loop over all these cells, okay? And check if the cell is an obstacle, which means it has the entry is true or 1. Then I search around this obstacle for free cells and mark any free cells that I discover with a cost of 100. Okay, so this should be easy. So you know, this actually a copy and paste from that part here, which we see in all our codes before. Okay, so whenever I found a neighbor for this obstacle, I just mark its cost as 100. Okay.
I see. Okay.
Dr. Mustafa.
Yes, Clark.
So would this just you would just basically have something going up, down, left, right, check the cost, and then explore that node if that cost is less than all the other costs? Is that how this would be implemented?
So yeah, but this is maybe, you know, very abstract. Yeah, very abstract explanation for it. Okay. So basically we explore around, we explore frontiers, we discover nodes. Okay. And we choose one of the discovered nodes to discover other nodes. How we choose this nodes, the nodes that we discover more nodes, which will be a frontier, we choose a frontier that has, or a node which has less cost. Until we reach the goal, then we end up or break the loop, and that's it.
So is our goal a specific cost, or is it just something that's just going to be indicated by goal node?
Yes, the goal has no cost. I mark it with 0 because, again, whatever the algorithm that you are using, it must reach the cost. It shouldn't avoid it, right? So if you add a cost to the goal node, then you implicitly are saying, okay, if this has a less cost, if this frontier has a less cost than this, maybe you will make more exploration while we are already reached the goal. So I mark the goal here with 0.
Got it. Thank you.
Okay, guys. So I will publish the homework today or tomorrow morning. Okay. The homework will be, again, the shortest path. It should be very easy for you. Plus, you will code this Dijkstra in C++. So I will give you also a hint how to do that. Okay, what kind of function you should use. Okay, and what should be the result. So here we have a color map in Matlab. In C we will not have this. So we'll do something to indicate the pass, for example, between the start and the goal. Okay. So that's it, guys. Okay. And if you have any question, I will be happy to answer. If you don't, then okay. So
Dr. Mustafa, you said coding in C++. Do you want that also due at the same day, or is that going to be a future assignment?
It would be, I will give you more time for this. So the shortest pass would be next week, but the C++ will have 2 weeks.
Okay, thank you.
Okay.
And that's the entire program, right?
Yeah, for the same problem, Dijkstras. Yes.
Okay.
Yes. And one thing here, because again, we don't, those guys in the administration, I don't know, have some problem with the kids. So the kids are in the university, but for some reason, I don't know why they didn't spread out, or they didn't deliver the kids to you. So I don't know. So we're gonna take also the next, the next Monday as a regular lecture, okay? And I will just give you another, another algorithm called the A star. This should be the last algorithm. We'll do something else or another topic afterwards. But A star should be the last, the last algorithm. But it will be a normal lecture. I mean, I will just, I will put a limit for the time. I cannot explain for 2.5 hours. So I will, for example, give you 1 hour, 1 hour and a half. Then we're gonna continue on Tuesday and Thursday. Okay. Okay, guys. Any other questions?
Mr. Mustafa, are you gonna have office hours right now?
I am very sorry. Because I have a department meeting right now. It actually starts.
Oh, okay.
So you can email me, or if it's something really urgent, we can talk tomorrow. I can meet with you on Zoom tomorrow.
It was just about the DFS code, but that was it.
If it's urgent, we can do it tomorrow. If it's not, we can after. So, guys, henceforth, the office hours will be after the lab. Okay. So 1 hour after the lab, or the remaining time after in the lab. For example, if we finish the lab early, okay, then we will take the remaining time as office hours as well, beside 1 hour after the lab. Okay. Just email me your issue, and we can. I will see if we need to have a separate meeting tomorrow, or just leave it to Monday. Okay, Johnny?
Sounds good. Thank you, Mr. Mustafa.
One last question, Dr. Mustafa. How do you base your grading schema on the code? Is it just if it works for all the examples, or is it how efficient the code is?
That's a very nice question. Thank you. So I have examples, right? So I will not look at the efficiency. Okay, I will assume, but of course I will look at the code, seeing what's really happening, because you have the examples. So I will run it on the examples, okay? And for example, I have 10 examples. So if it ran for 9 examples and they didn't give me the correct answer for the 10th, then you will take 9 out of 10. I am very generous in this, because it shouldn't, it shouldn't be correct if it didn't run with one of the examples. But this is coding, okay? You can't have some ultimate example through which you can know if your code is right or wrong. You cannot have this. It's really difficult. Okay, so we test our coding using benchmarks. This is our benchmark, the code, the example that I sent you, and I have other examples as well. So I will run your code using these examples. Okay, pass 1 mark, didn't pass 0 mark. So if it passes 5 out of 10, then it's 5 out of 10.
Got it. Thank you.
Okay, guys? Any other question? Okay. Okay.
Just one quick question. I was trying to look through your syllabus. Do you have a late policy on the assignments, or if it's late,
Yeah,
is there
so
like
if you look at the on Canvas, I put a deadline for each, 2 deadlines. Deadline for the normal submission, which is not considered late. Then if you exceed this deadline, okay, you have another deadline through which you can still submit, but it will be marked as late.
okay, okay,
After which you cannot submit.
okay. Thanks, Professor.
Any other question? Okay. See you next Monday. Have a great weekend. Bye-bye.
Thank you.